Okay, so this will be the last lecture. So the 5th lecture over chapter 2 and the last lecture. So in this lecture, we'll basically look at how to name chemical compounds. So we'll start off by looking at how to name ionic compounds. So if a cation only has one common charge, like sodium likes to be +1, magnesium likes to be +2, so you don't state the charge in the name. So we'll go through the rules right quick and then I'll work lots of examples. So if the cation is from an element that forms more than one common charge, so like 10 can be +2 or +4. Palladium is oftentimes +2 or +4. So if the metal forms more than one charge state, then you have to indicate what the charge is in the name of the compound. And so you use a Roman numeral to designate the charge on the metal, right? So if it's +1, a Roman numeral 1, if it's +2, a Roman numeral 2. So you have to remember how to write in Roman numerals, right? So 1, 2, 3, 4, 5, for example. So cations always come first in the name of a chemical compound and in the formula when you write the formula. So like sodium chloride, NaCl, sodium's a metal, chlorine's a non-metal, so the metal always comes first in the formula and the name. So anions, so you name the metal as itself. So sodium is the metal and Na is sodium, you just call it sodium. But the non-metal, you change the name from its element name. So anions are named by taking the name of the element and changing the ending to "ide." So Cl is chlorine, right? But Cl minus as an anion is chloride. O is oxygen, O2 minus. So if you remember from the last lecture, oxygen likes to be -2 charged. So O2 minus would be oxide. F is fluorine. If it's an anion, though, then it is fluoride. Right, sulfur, if it's an anion, becomes sulfide. So they all have the "ide" ending. Bromine becomes bromide. Nitrogen becomes, if it's N3 minus, nitride. Phosphorus would become phosphide. And iodine would become iodide. Okay, so 5th, you name the metal as itself, so you don't change the name of the metal. So let's take some examples. So NaCl, so table salt. So Na, the name of the metal is sodium, so that doesn't change, but chlorine becomes chloride. Right, so even though it's wrote NaCl, it is really Na plus and Cl minus, right? And Mg, if you remember from the last lecture, likes to be +2 charged, so this is really Mg2 plus, and there's 2 F minuses, but that's beyond what we're trying to do now. We're just looking at how to name this. So this would simply be Mg is magnesium, that's the name of that element. And then fluorine, right, F is fluorine, would become fluoride. Right, so magnesium is +2 charged, but you don't have to indicate the charge on the metal because magnesium always wants to be +2, and sodium always wants to be +1. Did I put a periodic table in here? Yes. So if you remember, group 1 likes to be +1, group 2 likes to be +2, so there's sodium and magnesium. So these elements, you don't have to put the charge in the name. These like to be +3, right, these elements. But then, of course, as you get down here towards the bottom, they could be +1 or +3, +2 or +4. And bismuth likes to be +3. Okay, those are very common charges, so you don't have to put the charge in the name. So here, lithium, Li is lithium. And then nitrogen would become, so this is really Li plus, right? There's 3 of them. And this is really N3 minus, and N3 minus is nitride. So that would be lithium nitride. Okay, so Ca is calcium. And then oxygen, so this is really Ca2 plus and O2 minus, and O2 minus is oxide. So this is rubidium, so rubidium's +1. and then sulfur is 2 minus, right? So rubidium is a group 1 metal, so it always likes to be +1, and sulfur is here, so this is in group 6, so +4, -3, -2, right? Sulfur likes to be -2, halogens like to be -1, and noble gases don't like to be any charge. Okay, so this would be rubidium sulfide. Okay, so now we have 10. And 10 is one of those metals that can be different charge states, right? It can be +2 or +4. So how do you know what it is? You know what it is because you know what chlorine likes to be. Chlorine likes to be -1, and there's 2 chlorine, so that's 2 negatives. So, and 10 has to balance that, so 10 must be +2 because it has to balance to 0, right? That has to equal 0. So then this would be 10 since, or if it was here, so this is -1, so that's 4 negatives from the 4 chlorine, so now 10 has to be +4. So since 10 is a metal that can be different charge states, you have to put the charge in the name and use Roman numerals to do that. So this will be 10, 2 chloride, and this will be 10, 4. Right, so you put the metal, and then in Roman numerals in parentheses, the charge on the metal, and then you name the anion. So if you just tell somebody you need some 10 chloride, nobody knows what you're talking about, because are you talking about SnCl2 or are you talking about SnCl4? 2 totally different chemical compounds. So you would not say sodium is +1, you would not say sodium 1 chloride, right? Right, because sodium is always +1. These main group elements that always have a common charge, you don't put the charge in the name. If you tell somebody you need some sodium chloride, any chemist knows exactly what you're talking about. You're talking about NaCl because there is no NaCl2 or Na2Cl, for example. Because sodium likes to be +1, chlorine likes to be -1, so it's always just 1-to-1 ratio, NaCl. But that's not true for 10. And the same is true for here for palladium. Palladium can have different charge states. So how do you, it's a transition metal, right? So palladium is, where does it go? Here in the periodic table, it's a transition metal. And you can't just look at the periodic table and know what the charge is going to be. Is it +1, +2, +3, +4? You don't know. So you have to use what it's attached to figure out what the charge is on it. And it's attached to bromine, and you know what bromine likes to be. Bromine likes to be -1. There's 2 bromine, so that's 2 negatives, so the palladium must balance that to 0, so it must be +2. So this would be palladium 2 bromide. And in this case, palladium would have to be +4, right? Since there's 4 bromines that are -1, then palladium must be +4, so this would be palladium 4 bromide. Okay, so some metals, some metal cations have common names that are associated with them from the older literature. So Fe3 plus, right? Iron 3, iron 3. If you're using the conventional way, then you would use iron Roman numeral 3, but iron 3 is oftentimes called ferric. Or iron can be +2, so if you're using the conventional way, then you would say iron in parentheses Roman numeral 2, but iron 2 is also called ferrous in the older chemical literature. So same is true for copper. Copper can be +1 or +2, so you could say copper Roman numeral 2 or copper Roman numeral 1, or sometimes you see copper 2 called cupric and copper 1 called cuprous. So the higher charge is given the ic ending, right? And the lower charge is given the OUS ending. So you could call this, so this would be iron 3, right? That would have to be 3+, since bromine's -1. So you could call this iron 3 bromide, which is what I prefer that you do. But iron 3 is also called ferric, so sometimes this is called ferric bromide. And so since chlorine's a -1, there's 1 negative, so this copper must be +1, so the more conventional way to name that would be copper 1 chloride. Right, you have to put the Roman numeral in there. So anytime you see a transition metal, Anytime you see a transition metal in the name, or one of these lanthanides or actinides, you need a Roman numeral. Or one of these elements at the bottom, right, that are of higher mass. You need a Roman element in the name so that we know what the charge state is on that metal. So you would call this copper 1 chloride, or since it's the +1, the lower charge state. Sometimes you would see this called cuprous chloride, right? Cupric chloride would be CuCl2. Okay, and so this is where it gets even harder because these polyatomic ions that you have to have memorized. So the ions we looked at before, where'd they go? Here. So they're all one atom, one atom, one atom. Those are monoatomic. Monoatomic ions. In this case, there are chemical compounds where two elements or more than two elements are bonded to each other, and then overall they have a net charge. So for example, nitrogen with two oxygens bonded to it with a -1 charge, this is what's called nitrite. If it's a nitrogen with three oxygens bonded to it and it's got a -1 charge, this is what's called nitrate. And you just have to memorize these, right? So there's lots of polyatomic ions. I'll email out a couple of PDF files that have all of the different polyatomic ions that I expect you to memorize. So there's no way around it. You just have to memorize these. So this is again part of learning the language of chemistry. If you want to do really well in chemistry, you have to learn to speak the language. So CO3 with a 2- charge, that is carbonate. If you add a hydrogen to it, that reduces the charge by 1. So this is what's called hydrogen carbonate, or sometimes it's called bicarbonate. So NH4 plus is called ammonium. OH minus is hydroxide. HS minus is hydrogen. Hydrogen sulfide. So all of these polyatomic ions you just have to memorize. So on the worksheet that I give you something like this. I give you the structure. I give you the formula, and I give you the net charge, and I give you the name. This is called acetate. So for now, all that you have to have memorized is this: the formula, the net charge, and the name. You don't have to know the structure yet. So once we get to about chapter 10, then you'll have to know the structure. But at that point, we'll look at enough chemistry that you can figure out the structure on your own. You don't ever have to memorize it. You can always figure it out. But the formula, the charge, and the name, you just have to memorize. So UCMnO4 with a -1 charge. You just have to know that that is called permanganate, right? CN with a -1 charge, you just have to know that that is called cyanide. So lots of memorizing to do. Okay, so we'll use this example. So sometimes elements form more than one compound with oxygen, like chlorine can have one oxygen attached, two oxygens attached, three oxygens attached, four oxygens attached. So we'll take these two first. So these two, so ClO2 minus is called chlorite, ClO3 minus is called chlorate. So then if you take chloride and reduce the number of oxygens by one more, so then you can use this hypo. So hypo means less oxygen, so ClO minus would be called hypochlorite. Or if you go the opposite way, if you add an extra oxygen, then per means you have more oxygens. So and it's the same with ite and ate. So ite is for lesser numbers of oxygen, and ate is for greater number of oxygens. And then hypo would be even less oxygens, and per would be even more oxygens. So we saw that here with nitrite and nitrate. So ate, so nitrogen with 3 oxygen has the greater number of oxygens, so it has the ate ending, and nitrogen with the fewer number of oxygens has the ite ending. So we see the same thing here. This is sulfate, and this is sulfite. So sulfur with 4 oxygen has the 8 ending, 3 oxygen has the ite ending. Okay, so lots of polyatomic ions to memorize. So this is phosphate. So now let's name some compounds that have polyatomic ions in them. So this gets a little bit trickier because you have to recognize those two elements go together to form a polyatomic ion, and that polyatomic ion is called hypochlorite. So this is sodium hypochlorite. It's not sodium chloride oxide, right? You have to recognize ClO goes together to make one of these polyatomic ions that has a -1 charge. And that would be why you have a 1-to-1 ratio, right? Because sodium is +1 charged and ClO minus is -1 charged, so there's one of each of them. Okay, so this you have to recognize ClO3 is one of the polyatomic ions you have to have memorized. That is called carbonate. And then sodium, so this would be sodium carbonate, right? Why is there 2 sodiums and 1 carbonate? Because you have to know the charge on carbonate is -2. So that's a -2 charge. So that C with 3 oxygens attached to it has a -2 charge. And sodium has a +1 charge, so you need 2 sodiums to balance the -2 charge of carbonate, right? So this would be, so ClO4 goes together, that's a polyatomic ion, so this would be lithium. ClO4 is perchlorate, right? Lithium has a +1 charge, perchlorate has a -1 charge, so there's one of each. Okay, here calcium has a +2 charge, so an SO4 has a 2 negative charge, that's why there's one of each, but you have to recognize, okay, so Ca is calcium, so you name the metal as itself, but then you have to have this memorized. SO4 is called sulfate, right, so calcium sulfate, and so this would be potassium. Right, so potassium has a +1 charge, but sulfate has a -2 charge, that's why there's 2 potassiums in this formula. Okay, so in this case, you have to recognize NH4 is one of the polyatomic ions that you have to know, and so is PO4. So NH4 is called ammonium. Oops. And PO4, so this is PO4 3-, NH4 has a +1 charge, and so that's why there's 3 of these to balance the charge on the 1 phosphate, which is -3. So this would be ammonium phosphate. Okay, so let's take this. So let's take these ions. So what would be the formula of the compound they make, and then what is the name of that compound? So nickel has a +2 charge, sulfate has a -2 charge, so they balance each other out. So you just need 1-to-1, a 1-to-1 ratio. So that would be the formula of the compound. And then this would be called nickel 2. So nickel's a transition metal, so you need to put the Roman numeral in there. So nickel 2 sulfate. Okay, so copper, so Cu is copper. So since this has a -3 charge, you will need 3 of these to balance that to 0. So you need Cu3 PO4, and or again, you can still do this. You can take that number there, there's a 1 here, and you can take that number there. So you need 3 coppers and 1 phosphate. So this would be copper 1, oops, phosphate. Again, copper is a transition metal, right? Copper is here, so you need the Roman numeral. Nickel is there, so you need the Roman numeral and the name to indicate the charge on the metal. Okay, so silver, Ag is silver. It's got a +1 charge, so this is silver. NO3 -1 is nitrate. They both have a negative. They both have a charge of one +1 or -1, so you only need 1 of each. So it would be AgNO3, so that would be silver 1 nitrate. And again, silver is a transition metal, so you have to have the Roman numeral in the name. Okay, and in this case, so ammonia has a +1 charge, carbonate has a -2 charge. Did we do that one? No. So you're going to need 2 of these to balance that -2 to 0. So if you have more than one polyatomic ion, then you have to put it in parentheses, subscript, however many of them you have. But there's only one carbonate, so you don't need a parentheses for that. And so this would be ammonium carbonate. Okay, so hopefully that makes sense. Okay, so naming binary compounds. If you have 2 nonmetals attached to each other, or it could be a metalloid, then the rules to name those are differently. So first of all, so some examples will be like this. So we're going to try to name these compounds: CO, CO2, SF4, HCl. And you probably know the name of CO2. So what's the name of CO2? So that would be carbon dioxide. So if you notice what we did there, so they're 2 nonmetals, right? Carbon and oxygen are both nonmetals. So carbon is here, oxygen is here. So if you have 2 nonmetals attached to each other, the rules to name them are different. Not totally different, but they are different. So what we have to do first of all is establish which of the 2 nonmetals is more metal-like in character. And you do that by just looking at the periodic table, right? The closer they are to the left of the periodic table, or the closer they are to the bottom of the periodic table, the more metal-like they are. So since carbon's to the left of oxygen, carbon's going to be more metal-like. Oxygen will be more non-metal-like. So the rule is then the most metal-like comes first in the formula, and it comes first in the name. And then you name it as itself. And then the second element will be the one that's the most non-metal-like, and it will have the "-ide" ending. So that's similar to the previous rules. So what is different is that you're going to add a Greek prefix to denote the number of each element in the formula. So you use mono for 1, di for 2, tri for 3, tetra, penta, hexa, hepta, octa, so forth. So carbon, since there's 2 oxygens, so dioxide, right? And here this would be carbon, only 1 oxygen, so monoxide. So if we name this, so sulfur is more metal-like than fluorine since it's more to the left in the periodic table, so it would come first in the name. So it would always be SF4, it would never be F4S, right? You always put the most non-metal-like one first in the name and the formula. So this would be sulfur. So the one that is more metal-like is always just, you name it whatever its name is. And then fluorine would become fluoride, but there's 4 of them. So that would be tetrafluoride. So hydrogen, HCl would be hydrogen, and Cl would become chloride. Okay, so N2O5, so there's 2 nitrogens, so that would be dinitrogen. And so 5 oxygens, so 5 would be pentoxide. And this would be boron. And 3 chlorine, so that would be trichloride. Okay, so it's important to not mix the 2 naming systems up. So if we go back to one of these, right? Where did it? So you would never say iron tribromide, right? So don't mix the 2 schemes up. If it's a non-metal and a metal, you name it like this. If it's 2 non-metals attached to each other, that is the only time you use these prefixes. Mono, di, tri, tetra. These are both non-metals, so you use these prefixes. Or if it's a metalloid and a non-metal, that's when you use the prefixes mono, di, tri. If it's a metal and a non-metal, do not use the mono, di, tri, tetra, and so forth. Okay, so some of these compounds have trivial names or common names associated with them. So H2S, is a toxic deadly gas. So the technical name would be hydrogen or dihydrogen sulfide, right? Or most chemists would just call it hydrogen sulfide. So N2O would be dinitrogen monoxide. But sometimes this is called NOS, or this is laughing gas. Or sometimes it's called nitrous oxide, would be its more common name. NH3, so the technical name would be nitrogen trihydride. The more common name would be ammonia, right? So H2O, the technical name would be dihydrogen monoxide. The more common name, of course, most people would just call this water, right? But every now and then on the back of the magazine cover, somebody trying to sell you something that can remove dihydrogen monoxide from your house or from your environment. So basically playing on people's fear of chemistry, because people hear dinitrogen monoxide, like, oh, I don't want no dihydrogen monoxide in my house, right? But that would just be playing on people's fear of chemistry, those people not recognizing that dihydrogen monoxide is just water. So they would just be selling you something that will dehumidify the air in your house. Okay, and then lastly, in this chapter, looking at how to name things, so name these compounds called hydrates. So hydrate is just a compound that contains water molecules weakly bound in its crystal structure. So this will be an example. So CuSO4. So if you see this dot and then 5 H2Os, that means this compound will, 1 CuSO4 will crystallize 5 water molecules with it into its crystal lattice. So this is the structure of it. So you can see here there's a water molecule, H2O. So the oxygen's red, the hydrogens are white, and then there's a copper atom. And then, so you can see the sulfates, SO4s in the molecule. Sulfur's yellow, and then the oxygens are red. But if you wanted to name these, so you just name this as normal, that's a metal with a polyatomic ion. So polyatomic ion, you'd have to recognize that as SO4, which is a 2 negative charge. So you have to know that it's 2 negative because that's how you figure out the charge on the metal. The metal is +2. So this would be copper 2 sulfate. And then there's 5 waters, so then what you say is penta. So now you use a Greek prefix for however many waters there are. So penta, and then you call water hydrate. So that would be copper 2 sulfate pentahydrate. So just a Greek prefix for however many waters there are, and then just call water hydrate and stick that at the end of your name. Okay, we will stop there.